I'm delighted to present Tony Hsieh. He's a professor in engineering technology and industrial distribution and joint appointment. He has a joint appointment with mechanical engineering here very close to Mexico in Texas A&M University. Tony has several publications in the area in manufacturing. He has also worked as associate editor in several journals, including the prestigious Industrial Robot, and also other reference journals. And he has published 72 papers in engineering education. And he got the PhD in 1995 in Texas Tech University. And as probably you know, he has a passion for preparing students to rapidly succeed in this world, engineering world. And he's talking about just of this topic. And I just want to introduce to Professor Tony. So this is yours, Professor Tony. You can start your topic, please.
All right, thank you. Good morning, everyone. It's my honor to present some experience to be a faculty member and a researcher at Research One institutions, Texas A&M University. So I will start with what is my motivations and why we pick engineering as a majors, and what I have done over the years, and then trace back to when I was in bachelor degree, what did I do? And then how do I decide to come aboard to US for graduate school? And now I'm working in US. And the last thing is what's next. The intent of this talk is to share my personal experience, and there's no right or wrong. It's just a matter of how you have planned and how do you execute, and then how lucky you are to some extent. When I was young, and I like to play with tools. I like to build things. And engineering to me is cool, and it's also a high paid professional. So I grew up in a family, my uncles, they fix air conditioner. So when I was young in high school, and I just watched them how they fix things, and I started to play with tools, different types of tools. In Taiwan, I also own a bicycle. So I start to mess around with my bicycle whenever it's broke. And how do I maintain it? And so I gradually developed the passions for engineering. How does engineering will contribute to the economies? We say engineering, it plays a significant role to support the growth and the development of the country economies. And most important thing is it will improve your quality of life. So what does engineering do? Start from biomedicines to build the infrastructures, road and bridges, water supply systems, and to communication, utilities, networks, and most importantly is the development of the food that we eat, also the material which to be used. This is a picture which kind of summarizes what engineering can do. For example, how do we develop renewable energies like solar panel, wind turbines to generate electricity instead of using the fossil fuel. In the medical field, you have biomedical engineering who use robotics and to do the precise and accurate surgery of the patient. It can also be in civil construction engineering, which you build bridges, dams, and roads, and to speed up, foster the growing of the economy of the countries. It can also in manufacturing area, which you produce goods, provide service to industry and to our daily life needs. You can also be in the computer engineering, which you look into network securities and how do you defend your network, and how do you secure the transmission of data from one point to the other points. So these are some of the examples of what engineer can do. I'd like to share about some of my research directions and what I have done, and therefore we can trace back what I was when I was in a bachelor degree. So my area is more on smart system design and Industry 4.0. So how can we build systems which can learn over time? For example, if you have a microwave, how can you talk to microwave and not to automatic prepare a cup of tea for you or coffees? For example, how can you develop a smart home? Therefore, before you enter your parking garage, the parking garage door will open, and then you can park your car. And then before you enter to your door, the door automatically open for you. When you enter to the rooms, how does it adjust the temperature for you? So all these things is involved in recognizing individuals' habit, individuals' images and features and signatures, and try to adjust the systems based on individual needs. The other one is, how do I use infrared imaging to do inspections in addition to the opticals? The third one is, how do we design technology to help students to learn better? And last one is micro and nano manufacturing. For example, how can we develop a micro-scale needles which will dispense medicines based on the conditions of your blood. These are roughly the awards which I received and from the National Science Foundations, and also some of the internal grants. So over the years, I have probably roughly 190 publications in referee journals and conference proceedings. These are systems which we developed, allow the engineer to do remote troubleshooting and diagnostics. This is a web page. From the web page, you can use a webcam to view the remote systems, and you can click on any one of these buttons to know the conditions of the current and voltage, and you can work with the remote user to troubleshoot systems. This is a simulation screen which simulates how system is running when you run the automated systems. We also have developed a robotic work cell for Texas Department of Transportations. What you are seeing here is an scale robot, has 3 different types of end effectors. And then The intent is to mix, to produce the cement motor based on the robotic work cells. So you have dispenser dispense the sand and the water, and you have mixer here to mix the water, the cement together, and you have end effector which make a scoop of the cement and deposit into the mold. And then you have different end effector to tamp this motor into the mold. Therefore, there's no air bubble inside the mold. And then here is a tamper. You can tamp the cement inside the bowl. Therefore, every scoop you take it out from the bowl will be uniformly quantities. Smart system is based on this syntax structures. So you have physical systems, which can be your microwave, can be your robotic work cells, can be your CNC machines, and then you have sensors that built inside your systems that provides the data. And then you have a cyber system which mimic how CNC will work, and you generate knowledge. And from here, you go through your control algorithms based on your knowledge, and then to make real-time adjustment to your physical system. That can be a CNC machines, can be a robotics. You can also have the sensor data which distribute to your Internet of Things device, right? We call your web page, your personal servers. You can also display the data within the Internet of Things, like your iPhone, your mobile phones. So you can do the real-time interventions to your systems. These are some examples. We have 3D printers here, which is making different types of materials. And we retrofit the 3D printer with different types of sensors, infrared, thermocouples, fan, also thermistors. The intent is to make sure your nozzle of the 3D printer is not overheat. So this sensor provides data here, and then from the data received, we can build cyber systems which corresponding to sensory data to say, well, if we're going to have thermal stress or not. And then from here, we dynamically adjust the temperature settings or the fan to make sure the nozzle is not overheated. So this is one of the examples. Smart irrigation system is referring to how do I retrofit existing irrigation systems with sensors and devices. Therefore, we know which part of the farm need how much water at that given time. So we have these different temperature sensors now plotting the soil, pH values, humidities, and it goes through a cyber system, which we have algorithm to compute how much water we need, and then provide feedback to the irrigation systems. And again, these are we call the wireless network, which do the real-time transmission of data and adjustment to the process parameters. The next one is how do I know the condition of the root of the plant? Is it too dry? Does it need waters? So can we do the non-destructive testing method to determine that? These are some images we simulate, use final element analysis, and you start filling. And then this is the images from infrared cameras, and we can see the root conditions. And then from there, we can determine the health conditions of the plant. Here is trying to use infrared to look at the bubble inside the object. So you can see these are plexiglass. There's a hole in the middle, and you can see the infrared images which has different heat signatures. This one is applied for understanding the geometry of the solder joints. We have lots of printed circuit board which stack over the others, and you cannot inspect the solder joint integrity through the visual cameras. However, you can use an infrared to do it. That's back to where I was from and how do I start it. I was born in Taiwan, and this is a small island, used to be called Formosa. But back to earlier years of Taiwan histories, and so Taiwan was occupied by Portuguese, and then after that was Japan, and then it became independent after World War II. And this is mainland China here. This is our national flag. I get my bachelor degree from National Taipei University of Technologies, and it's abbreviated as a Taipei Tech. So the university is famous for producing high quality of engineer. So many are former graduates, they become CEO or managers of a big industry within Taiwan. So for me to graduate with a job is not an issue. It's a matter of which job I want to pick. So what did I do when I was in school? Well, we have a very heavy course load, 148 credit hours in 3 years. So almost start from the beginning of the day, which is 6 o'clock in the morning. We had to take a bus, about 1 hour bus ride to school. By the time the class ends at 5, by the time I got home, probably 7 o'clock at night. And after that, we still had, we call it homework. So by about midnight, we finish our work and go to bed. So we have a very, very heavy course load when I was in school. I understand the importance of the language. As you might know, our natural language is Chinese. But at the time, I noticed if I want to be different, I need to pick up a second language. So I focus my attention to how can I learn English better. I often start in the library a lot, and I'm not as much interested in curriculum, extra class curriculum, since I have so many homework to do. I am not on the top of my rank. I'm not the number one in my class. So I also, when I was in school, I just interested in what I want to learn and how this that shape my future. And I read articles, I read trade journal to know what's new and what's coming. So at the time I focus more on quality control and assurance because there are lots of American companies then in Taiwan, and they all get a high-paid job. And then also focus on we call motion and time study. It has a certificate. So if you get a certificate, we call it NTM, you can do the time studies, and then they can hire you immediately. When I was in college, the computer was not very popular, and we had to learn write programming by writing code, and then go to a punch machine to punch the card line by line, and we submit the programs with a deck of cards and to the mainframe, main computers, and then they will process your programs, and you are not the result next day. It's very tedious. And then, but in that moment, I realized computer is going to be the future. So I learned BASIC, I learned Pascal, I learned COBOL. Some of these classes are, we call them technical elective, but I feel like that would be the future. So I learned 3 different types of computer programming. So after I graduate, I worked in automotive industry for 2 years, and I served in the Army for 2 years. And those time I keep thinking about, I need a graduate degree because my section chief in the automotive industry, it takes him 20 years to become a section chief. And I said, well, I better get a graduate degree. Otherwise, I'll spend my whole life in the automotive industry. So that's how I decide I need to get a graduate degree. So when I was in the Army, you have you don't have much free times. You only have Saturday and Sunday. So then I enrolled myself in YMCA class, English class. And my Saturday and Sunday, I just try to learn the spoken English in YMCA. So then I prepare so after I worked 2 years from automotive industries, and then apply for graduate degree in US. So I went to St. Mary's for my master's. And then my advisor introduced me to Texas Tech. So then I finished my bachelor PhD from Texas Tech. When I arrived in St. Mary's, I know exactly what I want to learn. I say I want to learn the most advanced manufacturing technologies. At that moment, it's called computer integrated manufacturing. And so what you're seeing here is one of the pictures. You have robotic work cell and 2 robots, and that will do a pick and place operations. When I arrived in St. Mary, I talked to the department head. I say I want to learn computer integrated manufacturing. And then I didn't see there's any equipment there. And then, he was astonished. Then he said, okay, I'm working on it. So then about a year later, there's a systems, computer integrated manufacturing system they purchased. And then I told him, I said, I want to be in charge of that systems. So I start to learn about how that system works, different languages, and how do I communicate robot with CNC machines, and then with conveyors and so on and so forth. So that start to build my research capabilities. At the same time, my department chair say, okay, I can support you since you want to learn about this. So that's how I start with St. Mary's. So the point is, I know what I want to learn, and do you know what you want to learn? And then do you have that courage to continue to pursue your dream? I think that's the takeaway. So once I start my master, then first thing is I want to do a thesis. And I exactly know what I want to do. I want to do computer simulations. I want to put the entire factory into a simulation models, because I work in automotive industries and in the quality control divisions, and we oversee 2 different factories, and we constantly monitor every single factory, every single section, their performance. And I say, wow, that's very tedious. Can I put the entire factory into a computer models? And that's what I did for my master thesis. I compared the just-in-time system with Kanban system using a discrete simulation modeling approach. So how do I pick advisors? I know what I want. I know what I want to do, and I pick an advisor which has similar interests. And my advisor was he was Antonio Dieck. So he was in St. Mary's, and then later on he moved back to Monterey Tech. So he might be still be in Monterey Tech. So he helped me to write on the proposal outlines, and after that I just followed our outlines to develop my thesis. At the time, I think computer was not very popular and expensive, very expensive. So I have 80 to 87 machines running the simulation 24/7. So in the middle of the night, every time I run simulation, it takes 8 hours. So middle of the night, I wake up, I change the setting, and let the computer continue to run. For my PhD, I think it's a little bit different, because you had the preliminary exams, right? You write your topics, and you write your proposals. And I wrote my proposal 2 times. And the first time I wrote it, and the committee has issue. And then I was discouraged, but I kept trying. And then 3 weeks later, I write a completely new proposals. So the point is, I just keep trying. Never try. In the end, what? You're going to get it. I think about this. This picture here, you are pushing a rod, which is relatively big. At times you don't know. But then when you start it, how do you narrow from area to a topic, and from a topic to a problem to be executed? And that's a tremendous task. And it just keep trying, and you will get it eventually. Complete a thesis, and that's day and night. I think it's a lot of revision, a lot of hard work. And I had 2 advisors. And so I set up this meeting with them every 2 weeks. So every 2 weeks, I finish something, I present to them, they comment on it, and then I revise it, and that's how it was done. Okay, so it was a long journey, but I finished it. Then I start to work, I graduate. The next thing is, okay, how I need a job, okay? I need a job, right? That's all the purpose is go abroad, come to US, you spend all this money, how do you find a good job? 2 things in my agenda. First one is I need a wife, because my mom connected me and said, hey, you are almost 30 years old, you need to marry. So if you are taking a long journey, why don't you bring a companion with you, right? Why don't you bring a companion with you? So I attend churches. I attend church, and I keep my eyes open. So I was in the choir. So lucky enough, I found a girl, and which appreciate my work. And when I was in St. Mary's, so she was helping me on my thesis writings. Though I studied English, okay, but it's not my first language, so always there's a gap there. But she was there to help me out, and so we continued to develop our relationship when I was in PhD. So then later on, we got married. The next one is once you have a job, how you will be evaluated, right? So from what I was told is you had to do the independent research. You develop your own thing, something that belongs to you, right? So how can you present your idea to them? How can you persuade your peer that this is your independent research topics? So the other thing is teachings. How do you teach a class, right? How do you teach a class? How do you develop syllabus? How do you do a laboratory development? So you're balancing with teaching, research, and service. So in the time we work with a team of faculty, so we approach Rockwell, and then we have former students working Rockwell. They are senior manager, so we told them what I need. And then also they are the giant within the automation control field. So I kind of work with them over 2 years, and then we design the instruments which I needed. In this case here, you have HMI, human machine interface, PLC controllers, and then you have we call the mini IOs, switch, push button, analog inputs. On the back of this box is a motion motor and drive, and everything is integrated together through the control net. So we work with industries, and the industry, first I developed a class which, according to my passions, computer integrated manufacturing, right? So automation control is my area. So I work with industries to develop the laboratories, and from there to develop the lab exercises, and then gradually develop my syllabus based on the input from industrial advisory committees. In terms of research, right, there are many. Where do you start, right? How many areas? So my point is you pick your best, right? So over the years, I've been developed expertise in computer integrated manufacturing, right? Or you call smart manufacturing. So I continue to work in that area. And how many of them? Well, I also developed the area in terms of using technology to teach, right? How can I use the technology to help students to learn? And then also I have developed this nano and micro manufacturing. And again, I start with automation and control. And then after that is using technology to teach. How do I use technology to teach? And then gradually broaden my area to infrared imaging and micro and nano manufacturing. The other thing is, how do I get fundings, right? I think NSF, National Science Foundations, at the time, Texas A&M, they send out a newsletter. The newsletter will tell you what are the call for proposal from what agencies. And I almost try every single one of them. But in fact, that's not a good idea. I think you should pick what you are good at. Otherwise, you spend a lot of time hitting the target, which is not a right fit to your expertise. How do I find students? When you are started as a junior faculty, it's very difficult. Fortunately enough, I was able to get NSF Career Awards. So I was 5-year grants, and I was able to tell students, hey, if you work for me, you can get supported until you graduate. So also, I do advertisement to every single department and tell them what I want. And then I interview students, supervise students. I think these are things you learn over time. When you start it, it's difficult. Often I just give students the proposal. I say, okay, this is my proposals, and we're going to follow this step to do it, because you have to think through it. And then how do you pick students? That's another challenging part, right? So some faculty will give the student to read papers and ask the student to summarize what they learned. But I was not that critical. I just asked students, tell me, can you work harder? Can you work diligently? And do you like my area? If you do, then I hire you. So how do you develop the research infrastructures? I think what I did is I worked with industries. And almost a lot of system integration company in US, I visited 25 of them because of my career grant. And from there, I learned what they need, and I can provide the students for them. So it's a mutual beneficial arrangement. And also attend the Rockwell Automation Fair every year. So we meet with companies, and then we describe to them what we are doing, and we know what they are doing. So they need qualified graduate engineers, and that's what we can provide. And that's how we collaborate and establish the relationship. How do you manage your project? Since you write the proposals, so you lay out the steps, and you just follow those steps. Service. How do I do the service? We often have a mentoring, we call the mentoring committee, which will provide guidance to you, say, hey, how much service can you have? Often as a junior faculties, they kind of ask you to minimize your service to departmental service. But over years, because of my exposure to NSF and also publication in American Society of Engineering Educations, so I gradually involved in some of we call the outreach activity, like as a panels and also as a program division chair for American Society of Engineering Educations. And also I was involved in Somerset's conference, SPIE conference. Okay, so how do I get a job? I think at the time I was trying to balance, do I get a job from industries or get a job from university? In my tradition, Chinese tradition, the scholar is well respected. So that's why I decided to be a faculty member. So I was faculty member in the UT-RGV for 2 years, and then I transferred to Texas A&M. How do I be recognized? I think depends on how much service you have within our societies, and then you gradually moving up the rank. Most importantly is, what does your family need? I think I stayed in Texas throughout my career because my wife had a job in San Antonio. So I was in UT-RGV, and then I was in Texas A&M, and then later on she moved along to College Stations. I want to show you a web page which kind of summarizes, we talk about it. So this is my web page. These are some of the projects. I'm going to show you some of the, this is a project with 3 other colleges. We designed curriculums for them. These are some of the more accessible systems. Uh, so there are two cameras. One of the camera is from the Cosmo. The other camera is looking at the entire workspace. It, in the interest of time, I would move on to the next one. So in this case here, we are trying to do the remote control of an articulate robot. So we have camera at 3 different views of the same robot. And we have a virtual teaching pendant here. You can manipulate the teaching pendant to move the robot. There are other systems. For example, we use a Unimetry printer to help students to learn about CNC programming. All right, so what you are seeing here is a Unimetry printer. You have a camera here to look at isometric view. We also add additional camera to give a top view. So in this case, you can monitor the object which is being printed. and at the same time, you can use a CNC code to control these 3D printers. All right, so these are the camera. Has to, this is the top view of the camera. This is isometric view. You notice there's always a time lag in so how to improve time lag is a research questions. There are many other projects which we have on the web page. I will let you to explore. This one here is virtual POCs. How do we use the animation to help students to learn some of the instruction within programmable logic controller? For example, timer on delays. So what you are seeing here is a virtual clock of the timers, and these are, we call the this pause and play button allows you to play the animations, and these are the, we call the input switches on and off. These are the outputs, and this is the program instructions of the timers. And then so the intent is to help students to visualize the concept when each bit will be energized and why. And they can play, pause and play, and try to grasp materials. The initial web page was developed in Flash, and the Flash is no longer supported. So that's why we capture the animation into a video and post on YouTube. We are in the process of converting the web page using the Adobe Animate. Therefore, the web page will be accessible to the audience in the future. At this point, I'd like to conclude the talk and like to answer any question which you might have.
Yeah, many thanks for your presentation, Tony. Very exciting career from Taiwan to US, and also giving this very interesting topic to our students in Mexico. And we're here waiting for someone who raised the hand for starting the question. It can be in Spanish as well, en español o inglés. Hi, Jose Francisco. You can start.
Again. Hello, Professor Tony.
Yes. How are you?
My question will be about you travel from Taiwan to US for studying, and we in Mexico want to get students from abroad. So very, very honest, you don't choose Mexico because which reason, or another country, or in other words, do you think in these days, 2022 almost, one student, a young student from Taiwan or China maybe, would like come to Mexico to maybe not for the complete PhD, but maybe for one year for experience?
Uh,
Do you think we have some chance to get
Yes,
students
yes.
from your country?
Yes, I think it's a very good idea. I am the we call the honorary international chair professor with Taipei Tech, and they do have we call exchange programs. They want to establish the relationship with other universities around the world. Some of them with Japan, Korea, US, and I think they would be eager to work with Mexico as well. And then they also recruit students all over the world from Taiwan. In fact, I just co-authored with one of the students from South America. So he went to Taipei Tech for his master. And then I helped them to convert his thesis into journals. So the journal is being published in the International Journal of Advanced Manufacturing Technology. So it's a very workable, it's very possible, yes. And especially, go ahead.
Yeah. No, yeah, thank you very much. That's a very nice information, because we always look to US because we are very near and everything, but we need to see to another countries. South America is also some places that we look because of the language and the culture, but we don't look to Asia. I think we need to begin to start collaboration and relations
Yes,
with Asia, I think.
Taiwan is when I was growing up, we don't have enough university, and then but later on, they start to build more and more university, and then but the society is changing. People does not like to have kids because it's too expensive to raise the kids in Taiwan. And so it is a good news because so many universities now and they need students. So they recruit students all over the world. And as I mentioned to you, Manuko, he's from South America and he came to Taiwan and he got his master and he was supported as a research assistant. And then I told him when I visit Taiwan, I say, hey, I can support you for a PhD if you come to US for PhD. But then because his family, he has to work. So he came back to, I think it's Ecuador. He came back to his countries and then he started working. And then when I met with him, because the center which I collaborate with is additive manufacturing. So they build different types of additive manufacturing system 3D printers for different applications. In his application is photolithography. So we continue to communicate after I came back to US during the winter trip, and then later on we encourage him to submit to revise the thesis into a manuscript, and then submit into a journals, and then also do the revisions, and that's not easy because he was a little bit scared because it's a lot of revision work. And then we just encourage him, say, hey, this is what you need to do. And then he just followed the steps. And then the paper just been accepted in, I think it's October. So I see it's very possible for international collaborations with Taiwan. And I'm more than
Very good.
happy. I'm more than happy to help to establish that relationship.
Oh, thank you very much.
Okay.
Yeah, we will look forward to do some collaboration. Thank you.
Welcome. You're more than welcome to work with you, Texas A&M as well. I think there's a Texas A&M concept program, right? I work with Isabel.
Okay, I don't know that program, but
yeah, we can let you know the details later. But yeah, that is a current program within CONACYT and Texas A&M.
thank you.
Oh, welcome.
And yeah, Tony, Taiwan is a very strong country, and you know that nowadays we don't realize that this chip problem worldwide, and in Taiwan, the TSMC company is a huge company around the world. It's Taiwan is very strong in this area. So I don't know if there is any other question. A quick question. We will end this session. Okay. We want to thank you, Tony, in the name of the organizers for your very, very interesting topic.
Thank you. Thank you all. Have a nice day. Thank you.
Bien, buenas tardes.